Hello everyone, welcome to this session. I am Dr. Sharmila, Assistant Professor, Department of ECE, Krishna Engineering College. In this electronics engineering lecture series, today we are going to see about the PN junction diode. So the learning outcome of this section, in this section we are going to see about what is PN junction diode, the construction of PN junction diode and working of PN junction diode under forward biasing and reverse biasing condition. Then we are going to see the VI characteristics of PN junction diode. So before we go into the lecture, PN junction diode, I am just going to revise the topics which we saw in the last lecture. The last lecture I have discussed about the types of semiconductor material. So you know that the semiconductors are classified into two types, that is intrinsic semiconductor and extrinsic semiconductor. So you know that intrinsic semiconductor is also called as the pure form of semiconductor. The extrinsic semiconductor is also called as the impure form of semiconductor. So the examples for intrinsic semiconductors are silicon and germanium. The extrinsic semiconductor is classified into P-type and N-type semiconductor material. In what is the meaning of N-type semiconductor material is, in the N-type semiconductor material, so the majority carrier is of electron, minority carrier is of the holes. Okay. In the N-type semiconductor material, what types of trivalent, we are going to use the pentavalent impurities to added with the pure form of the semiconductor. What is the meaning of pentavalent? Pentavalent means the atom which has 5 valence electron in the outermost shell. Okay. So in the N-type semiconductor material, the majority carrier is an electron. In the P-type semiconductor material, the what types of impurity we are going to add is trivalent impurity. What is the meaning of trivalent impurity? Tri means 3. So the atom which has the 3 valence electron in the outermost shell, that elements we are going to add with intrinsic semiconductor. Okay. So last class we discussed about the types of semiconductor, that is P-type and N-type semiconductor in detail. Okay. So in this lecture we are going to see about PN junction diode. Okay. So what is the meaning of PN junction diode? This PN, that is the first one is the diode. The diode term was initially coined by William Henry Eccles in 1917. So what is the meaning of generally diode is, the diode is nothing but diode. Di means 2, ode means electrode. Okay. So this PN junction diodes is a base for all the diodes. So there are so many different types of diodes are there, like PN junction diode, LED, laser diodes, photodiodes, etc. So now we are going to see about the PN junction diode, because this PN junction diode is base for all the other diodes. Okay. So what is the meaning of PN junction diode? So the PN junction diode is nothing but we are just going to join P-type material with N-type semiconductor material. That is the PN junction diode. So in this diagram, this is the construction of the PN junction diode. So here the P-type material is joined with the N-type material. Okay. So there is an electrical isolation between the P-type and N-type material. That electrical isolation is called as the junction. Okay. So important point what you have to know, what is the meaning of PN junction diode is, the PN junction diode is constructed by joining the P-type material with N-type material. Okay. So there is some electrical isolation between this P-type and N-type material, that is called as the junction. Okay. So this is the construction of the PN junction diode. So we are going to see the working of PN junction diode under the 3 conditions. So first condition is unbiased condition. Then we are going to see about forward bias and then reverse bias condition. So what is the meaning of unbiased? Unbiased means we are not going to apply any external voltage to the diode. Just we are going to see the simply the construction of PN junction diode. Okay. So in this PN junction diode, here there is no supply is applied. Okay, that is VD is equal to 0 volt. So this is nothing but the unbiased condition. Okay. So during this unbiased condition in the PN junction diode, you know that in the P side, the majority carrier is the hole. In the N side, the majority carrier is an electron. Okay. When you join the two material, like opposite material, that is P-type material with N-type material, the opposite charges always attract each other because the hole is a positive charge particle, electron is a negative charge particle. So the opposite charges always attracts each other. So the electrons from the N sides moves towards the P side region, and the recombinations of electrons and hole take place near the junction. Okay. So that process is called as the diffusion process. What is the meaning of diffusion process? It is very important one. So the diffusion process is nothing but when you join the two different material like P-type and N-type material. So the P-type has the holes, N-type has the electron. Okay, when you join the two different material, the opposite charges attracts each other. So the electron from the N side cross the junction and attracted towards the hole in the P side region. Okay, so in the P side region, the recombinations of the electrons and hole take place. This process is called as the diffusion process. Okay, so initially this diffusion process takes place for some period of time. After that, this is a junction, you know, in between the P-type and N-type material, it is a junction. After some particular period of time, what will happen? In the P side material, the negative immobile ions are formed near to the junction. Similarly, in the N-type material, the positive immobile ions are formed near to the junction. Okay, so this medium is called as the depletion region. So what is the meaning of immobile ion is, suppose when the electron in the N side region tries to cross the junction, that time this immobile ions in the P side. Immobile ions in the P side is a negative ion. Negative means what? It is of an negative ion, acceptor. Okay. So the negative ions in the P side region, it does not allow the electron to cross the junction. It will repel the electrons towards the N types, towards the N type material. Okay. Okay. So you know that this is the construction of PN junction diode. Here this blue color is of an electron and circle one is the hole. Initially what will happen? The electrons cross the junction and reaches the P side, and the electrons are recombined with the hole in the P-type region near to the junction. The recombinations of electrons and hole is called as the diffusion process. After the diffusion process, the negative immobile ions are formed in the P-type material near to this junction. And similarly, in the N-type material, the positive ions are formed in the near to the junction of N-type material. Okay. So these two immobile ions are act as a barrier. What is the meaning of barrier? Barrier is just like a wall. Okay. It does not allow the electron in the N side to cross the junction and moves towards it, the P-type. Okay. So what is the meaning of depletion regions? The immobile ion formed near to the junction in P-type and N-type region is called as the depletion region. So what is the meaning of depletion region? This depletion, that is this ion, that is negative ion and positive ions, deplete the charge carriers. Okay. So the region is deplete of the charge carriers. Hence it is called as the depletion region or depletion layer or space charge region. Okay. So due to the presence of this positive and negative ion in this depletion region, the electrical field is produced between these immobiles ion. This electrical field does not allow the electron to cross the junction and moves towards the P-type. So that's why it is called as the, there is a barrier potential is formed in the depletion region. So due to the presence of negative ions, that is negative immobile ion, so positive immobile ion across the junction, the electrical field is created between these two ions. Okay. So it is act as the potential barrier or junction barrier or cut-in voltage. Okay. So this is the working of the working of PN junction diode under the unbiased condition. During the unbiased condition, important thing is there is no current flow in the PN junction diode. Okay. So here the electrons and hole, there is a no movement of electrons and hole. So for that reason, we are going for biasing. So important thing what you have to know, during the unbiased condition, it creates a depletion region near to the junction. What is the meaning of depletion region? The depletion region is nothing but the positive and negative ions are formed near to the junction. That ions are act as a barrier. Barrier means what? It acts as a wall. It does not allow the electrons or hole to cross the junction. Okay. So during the unbiased condition, there is no current flow in the PN junction diode. That means the current flow is zero only. Okay. So next we are going to see about biasing. So, okay, this is an unbiased condition. Already I explained you. Unbiased means we are not applying any voltage here. That is, we are not applying any external source here. There is a no movement of electrons and current. So, the diode current is equal to 0 milliamps. Okay. So, why there is a no current? Because there is a no movement of electron. In the semiconductor device, the flow of current is depends on your movement of an electron in the material. So during the unbiased condition, there is diode current is equal to 0 because there is a no movement of electrons in the semiconductor material. Okay. So next we are going to see about the biasing of PN junction diode. So you have to know what is biasing. Why we are going for biasing? Okay, you know that if it is of unbiased condition, unbiased means what? In the PN junction diode, we are not going to apply any voltage. Okay. So in the unbiased condition, the current flow is zero. Okay, the current flow in the diode is zero because of the no movement of electrons in the PN junction diode. In order to move the electrons and holes in the PN junction diode, we are going for biasing. What is the meaning of biasing? Biasing means we are going to apply some external source. What is the meaning of external source? For example, you can take any DC supply or some small battery you can apply. Okay. So what is the meaning of biasing? So biasing is the connection of external source. External source means what? Some supply. We are going to give some external energy using a battery, or you can use here some DC supply too. Okay. Why we are applying the energy to bring the movement of holes and electrons in the PN junction diode. Okay. So the process of applying some external energy to the PN junction diode is called the biasing. In any device, if you are applying some external source, okay, that is called as the biasing. The biasing is classified into two types. One is forward biasing, second one is reverse biasing. Okay. So here this diagram shows the symbol of PN junction diode. Okay, so this is the symbol of PN junction diode. So here this side is of the positive terminal. We can call it as an anode. That is our N-type material terminal, and the P-type terminal material. In the N-type terminal material, it is called as the cathode. That is of a negative. Okay, so this is the symbol of the PN junction diode. Okay, now we see about what is forward biasing. So what is meaning of forward biasing is, I already told you, the biasing means what? We are going to apply some external source. External source means what? Here I am just going to apply some battery. Okay. So this is the symbol of battery. You know that the positive is lengthy one and negative is a shorter one. Okay. So during the forward biasing, I am just going to connect the P-type material is connected to the positive side of the battery. N-type is connected to the negative side of the battery. That is forward biasing. So what is the meaning of forward biasing? The positive terminal of the battery is connected to P-type material. So that is nothing but anode terminal. Okay. Similarly, the negative of the battery is connected to the N-type material. That is nothing but cathode. Okay. So that is a forward biasing. Next, you have to know the reverse biasing. So reverse biasing is just opposite. Okay. In the reverse biasing, so the negative terminal of the battery is connected to the positive terminal of the diode, that is anode of the diode. The positive terminal is connected to the negative terminal of the diode. The reverse biasing is just opposite to the forward biasing. Reverse biasing, the positive terminal of the battery is connected to the negative terminal of the diode, and the negative terminal of the battery is connected to the p-type material. Okay, this is the forward biasing and reverse biasing. Why we are going for forward and reverse biasing is to in order to move the electrons in the PN junction diode, we need to apply some external energy. For that, we are going for biasing. Okay, so you know that in unbiasing condition, the potential barrier is created in the depletion region. In order to break the potential barrier, we need to apply some energy. Okay, so that is the use of biasing. So now we are going to see about the working of PN junction diode under forward biasing and reverse biasing. So first, forward biasing. As I said earlier, the forward biasing means what? The positive terminal of the battery is connected to the p-type material. Negative terminal of the battery is connected to the n-type material. Okay. So if you connect the positive terminal to the n-type material, negative terminal to the n-type material, we know that the same charge always repel each other. The opposite charge always attract each other. Okay. For example, you take a magnet. In the magnet, if you are facing the north and north pole, means what will happen? The same pole always repel. Okay. If it is of opposite pole, like north pole and south pole, if you just place it together, it will attract. Okay. Similarly, in this PN junction diode, in this electronics also, the same charges always repel each other. The opposite charges always attract each other. Okay. So because of this positive supply terminal at p-type material and negative terminal at n-type material, the electrons and holes are repelled from the battery and moves towards the junction of the PN junction diode. Okay. So the electrons get enough energy to break this electrical field formed in the depletion region and cross the junction and moves towards the p-type material. Then the recombinations of electrons and hole take place. If the recombinations of electrons and hole take place, what will happen? The current start to flow in the PN junction diode. Okay. So the main important thing is when you apply the same, that is when you apply the positive terminal of the battery to the p-type, negative terminal to the n-type material, the same charges always repel each other. So the electrons are moves towards the junction of the PN junction diode. Okay, it get enough energy and break this electrical field and moves towards the p-type material, and then the recombinations of electrons and hole take place. When you increases the forward biasing voltage, the movement of electrons will increases. If the movement of electrons will get increased, means what will happen? The more amount of current flow through the PN junction diode. Okay. So the another one important thing you have to know, what is the meaning of knee voltage? So the knee voltage is nothing but the minimum voltage required by the diode. So already I told you that so the diode is made up of silicon and germanium material. Okay. So when you apply that means when you increase the diode voltage, what will happen? If you are using a silicon material, it need a 0.7 volt to break the potential barrier created in the depletion region. If you are using a germanium material, means so once the voltage increase above 0.3 volt, what will happen? The electron gets enough energy and break the electrical field. The current, that is electrons moves very fast. If electrons moves very fast, what will happen? It will increases the current flow. So the knee voltage is also called as the cut-in voltage or threshold voltage. So knee voltage means what? The minimum voltage required for the diode to increases the current conduction. Okay. After this cut-in voltage, for example, if you are using a germanium material, the knee voltage is of 0.3. When you apply increases the diode voltage above 0.3, 3 volt, the current diode current start increase exponentially. Okay, similarly for silicon, it is of 0.7 volt. When the diode voltage increases above 0.7 volt, what will happen? The diode current increase exponentially. So the knee voltage means the minimum forward voltage after which the diode current increase exponentially. Okay, so that is the knee voltage. Okay. So this is the VI characteristics of PN junction diode under the forward biasing condition. In y-axis, we are going to take the forward current. In the x-axis, we are considering the forward voltage. So forward voltage means what? The voltage which we are applying using a external energy, that is the battery or any other power supply. Okay. So for example, here I am considering this VI characteristics for the silicon diode. You know that for silicon diode, the knee voltage is of 0.7 volt. Okay. When you apply the voltage from 0 to 0.7 volt, here the current is increasing very slowly. That means what? The electrons not get enough energy to break the electrical field when the voltage is increased above this knee voltage. Knee voltage is also called as the cut-in voltage or threshold voltage. When the voltage is crossed 0.7 volt, then the movement of electrons will increase. That means the electron breaks the potential barrier and the current start increasing exponentially. Okay. So in the y-axis, you are considering the forward current. In the x-axis, it is of the voltage. During the forward bias condition, there will be a current flow. We are measuring the current in terms of the milliamps. Okay. So that is the things I've given here. When the externally applied voltage increases, the more and more number of electrons and holes cross the depletion region. That means it will break the electrical field and produce the more current. Okay. So you know that the conventional flow of current is just opposite to the flow of electron. You know that the electrons are moved from the N type to P type material. So the current flow is opposite direction. That is the current flow from the P type to N type. Okay. So next we are going to see about reverse bias condition. Already I told you what is the meaning of reverse bias. The reverse bias means what? The positive terminal is positive terminal of PN junction diode is connected to the negative terminal. The negative, that is the negative terminal of battery is connected to the N type material. You just see this diagram here. Okay, here this P type material is connected to the negative terminal of the battery. The N type terminal is connected to the positive terminal. As I said earlier, if it is of this, okay, here if it is of the opposite charge, okay. Okay, here it is of the opposite charge, that is P type is connected to negative, N type is connected to positive. If it is of opposite charge, you know that it always attracts each other. Okay, so once you apply this reverse bias voltage, the electrons and holes are attracted towards the external source, that is nothing but a battery. Then what will happen? The width of the depletion layers get increased. That means the more number of negative ions and positive ions are formed near to the junction. So in the forward bias condition, the width of the depletion layer is decreased. In the reverse bias condition, the width of the depletion layer get increased. Okay, if the width of the depletion layer get increased, means what will happen? The large potential barrier is created across the junction. So it is very difficult for the electron to cross the junction and moves towards the P-type material. Okay. So when the diode is connected in the reverse bias condition, so reverse bias condition means what? The positive voltage is applied to the N-type material, the negative voltage is applied to the P-type material. Okay, when you connect diode in the reverse bias condition, all the electrons and holes are attracted towards the battery. So the width of the depletion layer get increased. Width of the depletion layer get increased means large amount of immobile ions are formed near to the junction. So what will happen? It creates a high potential barrier is created across the junction. So it will prevent the flow of the current. Okay. So that means in a reverse bias condition, due to the majority carrier, the current flow is almost 0 amps, but there will be a small amount of current flow due to the minority charge carrier. Okay, you know that in the p-type material, a majority carrier is of the hole and then the minority carrier is of electron. So due to this minority charge carrier electron, okay, so this electrons will diffuse with the hole and produce a small current. That current is called as the reverse saturation current. So due to the majority carrier, there will be no current flow in the PN junction diode under the reverse bias condition. Due to the minority charge carrier, there will be a small amount of current flow in terms of nano amps. Okay, that current is called as the reverse saturation current. It is very important one. What is the meaning of reverse saturation current? The small amount of current flows in the PN junction diode because of the minority carrier. So minority carrier is electron in the p side. It tries to cross the junction and the recombination take place. So small amount of current flow in the reverse bias condition. Okay. So next we are going to see about, I am just to give one diagram to understand easily. Okay. So this is the PN junction diode. Already you know that the depletion layer is formed between the anode and cathode. When you apply the reverse bias, so once you apply the reverse bias condition, you know that the opposite charges always attracts each other. So the positive, that is the holes are attracted toward the negative side, the electrons are attracted toward the positive side. That means what? The electrons and hole near to this junction, okay, near to this depletion region, move away from that region and moves towards the battery. So what will happen when the electrons and holes moves towards the battery means, so here there will be a no free electrons and holes in the near to this junction. Matlab means the depletion region width is increased. When the depletion region width increased, the more potential barrier is created across the depletion region. So it does not allow the current to flow through it. That is, there is a no movement of electron means there will be no current in the PN junction diode. But due to this minority charge carrier, still the PN junction diode has a minority charge carrier. Because of this minority charge carrier, the small amount of current produced in the PN junction diode. So it is in terms of the nano amps. That current is called as reverse saturation current. Okay. So it is a VI characteristics of PN junction diode under the reverse bias condition. So when you apply the reverse voltage, you know that in the y-axis we are going to consider the current, in the x-axis of reverse voltage. When you increases the reverse voltage, you know that there will be a small amount of current flow. There is a small amount of current flow due to the minority charge carrier, that is reverse saturation current. So there is a constant current, that is a reverse saturation current flows through the diode. Okay. When the reverse voltage is increased beyond this threshold level, this threshold level is called as the reverse breakdown region. When the reverse bias voltage is increased above this reverse breakdown region, what will happen? Suddenly the large current flow in the PN junction diode under the reverse bias condition. In the next topic, we will see about the reverse breakdown region. It is also called as the Zener breakdown region or avalanche breakdown region. Okay. So if the current flow increase suddenly means what will happen? Okay, it will damage the diode also. Okay. This is the VI characteristics of PN junction diode. So this is the overall VI characteristics of diode, both forward as well as the reverse bias condition. You know, during the forward bias condition, when you apply the forward diode voltage, initially it start to increase. When the forward voltage reaches the knee voltage, that is cut-in voltage, then the electrons moves very fast. That means the current, it will increases the current exponentially. Okay. For the silicon, its value is of 0.7. Germanium, the cut-in voltage of 0.3. Above this cut-in voltage, the current flow will be very high in the forward bias condition. So during the reverse bias condition, you know that there will be the no current due to because of the majority carrier. But due to the minority carrier, there is a small amount of current flow. The current flow is in terms of the nano amps. Okay, once the reverse bias voltage increased above this breakdown voltage, what will happen? Suddenly the large current flow in the PN junction diode. This large current flow, what will happen? It will damage our diode also. Okay, so this threshold is called as the reverse breakdown voltage, or we can call it a Zener breakdown or avalanche region. Okay, so in this lecture, we saw about the PN junction diode, VI characteristics of PN junction diode also. Okay. So here now I gave some learning by doing activities. So just to pause the video and go through these three questions. Okay. So whatever the knowledge you learn from this video, okay, using that one, you are just going to solve these three. So just to pause the video and try to answer these three questions. Okay. So I hope that you have answered for these three questions. So now I will discuss the answer for these three questions. So in the PN junction diode with no external voltage, so the electric field between acceptors and donor ion is called what? Okay, you know that no external voltage means what types of condition it is? It is an unbiased condition. So during the unbiased condition, you know that the electrical field is formed between the acceptor and donor ions. So acceptor and donor ion means what? Negative ions and positive ions. Okay. In the p side region, the more number of negative ions are formed, that is immobile ions are formed. In the n-type material, the more number of positive immobile ions are formed. Okay. So due to this, there is some electrical field is formed between acceptor and donor ion. That is nothing but a barrier. I already explained you what is the meaning of barrier potential. So the barrier potential is formed between the acceptor and donor ion. Don't confuse with acceptor and donor with the positive and negative ions. Okay. So in the p side, the negative ions are formed. In n side, positive ions are formed. In the p type, the majority is the acceptor. N type is of donor. Okay. So next question is, how many junctions do a diode consist? You know, it is very simple. So the diode consists of only one junction only. Okay. So during the reverse bias, the small current develop is known as. You know that during the reverse bias condition, there will be no current, but small amount of current flow in the PN junction diode under the reverse bias condition. That current is called as the reverse saturation current. Okay, the reverse saturation current is nothing but the small current flows in the PN junction diode due to the minority charge carrier. It is very, very important one. Okay. So I hope you have understood all that working of the PN junction diode. In the next video, we will see about the ideal and practical characteristics of PN junction diode. Okay. So thank you.